multiple choice questions. Question 5. The table shows a standard enthalpy of formation for some of the substances in the reaction. What is the standard enthalpy of formation in kilojoules per mole to power minus 1 for HF? Okay, we know C2H6 minus 84, C2F6 minus 1344 plus 6x. And obviously that's going to be 0 because that's an element in itself. So enthalpy of formation, enthalpy of products minus enthalpy of reactants. So it's going to be minus 1344 plus 6x minus 84. Minus 1344 minus 84 minus 84 minus 1260, and if we add that on and do that divided by 60, enthalpy of products minus reactants, enthalpy of formation data, right? So it gives us delta H. Can't believe I haven't seen it. Obviously it gives us delta H, so let's rub that out. That's why. So it's going to be minus 2898 equals minus 1344 plus 6x minus 84. Then we get minus 2898 equals minus 1344 minus 84, 6x minus 1260 minus 2898 plus 1260 divided by 6 minus 273. Answer is B. Question 6. Questions about the reaction given below. Enthalpy data for reaction species are given in the table below. It is formation data because I can clearly see that's a little F there. And just knowing that, I know the formula. Enthalpy of products minus reactants. I know CO is minus 110. Okay, so it's going to be delta H. Yeah, we're trying to find delta H. Minus enthalpy of products minus 394. Minus enthalpy of reactants minus 110 plus minus 242. All have 1 moles of each other, so don't need to worry about timing by anything. Just put it in the calculator. 110 plus minus 242 minus 42. Therefore, the answer is B. Question 7. When 0.10 grams of propane was burned, the quantity of heat evolved was that. The enthalpy of combustion is... Okay, enthalpy of combustion formula delta H equals Q divided by number of moles. Now, am I going to have to use Q equals MC delta T to work out Q? Am I going to have to use moles in mass over MR? I'm not going to have to use this because I've already got this. Quantity of heat evolved 5 kilojoules, which is the same as 5,000 joules. But we want enthalpy of combustion in kilojoules, so we are going to have to leave it in kilojoules. Okay, that's a bit tricky. Or do we leave it in kilojoules? Anyway, first we need to work out the moles of the alcohol. Moles of propane in this case. Moles of propane, which is the mass 0.10 divided by the MR. And the MR propane, methane, ethane, propane, C3, because it's an alkene, C and H2 plus 2, C3H8. Now I can work out the MR, 0.10 divided by 12 plus 12 plus 12 plus 8. Then I'm going to do my answer divided by that. And I should get 2,200. And we do leave Q in kilojoules because we do want our final answer enthalpy of combustion kilojoules. So now I got 2,200. None of these values are 2,200. They're all negative values. The reason they're negative is because this is exothermic data, so it's going to have to be negative. Therefore, my answer is C. You know, it's just a sign that changes. The value doesn't change. It's just a sign. If it's endothermic data, it would be positive. Question 8. Calculate the enthalpy in kilojoules for this dissociation of mole of propan-1 of enthalpy change. Give a mean bond dissociation enthalpy. Energy required to break bonds minus energy released when new bonds are formed. So I think what we're going to have to do is first draw out C3H7OH 1, 2, 3, 4, 5, 6, 7 OH. Okay, and now we can see we've got this many bonds of this. But that's not the key thing. We've got a CO bond and we've also got OH bond. And then we're going to do energy required to break bonds minus energy released when new bonds are formed. So we've got 3 carbon-carbon bonds, 3 times by 348 plus 8 H's by itself. So we're not going to include that because we don't have the mean bond dissociation enthalpy for that. Plus O. No, we don't have the mean bond dissociation enthalpy for that. So it's going to be just 3 times by 348. 1044. So minus 1044. So we've got 348 times by 3 plus, yeah, 1 carbon bond, 2. No, we've only got 2. See, it gets tricky now. 1 carbon, that's only 1, that's 2. So we don't have 3 carbon-carbon bonds, we only got 2 carbon-carbon bonds. It's going to be 2 times by 348 plus 1, 2, 3, 4, 5, 6, 7 CH bonds plus a CO bond plus an OH bond. 4403. My answer minus 1044. Oh yeah, if you've got 3 carbon bonds, it's not going to be 348 times by 3. It's going to be times by 2. Oh my days. Now I'm going to have to go through. Okay, so it's going to be 348 times by 2 plus 412 times by 7 plus CO bond 360. Just cancelled everything I was just doing. So 348 times by 2 plus 412 times by 7 plus 360 plus 463. That's 4403 minus 348 times by 2, 696. Sorry, not minus 696. It's because these are single elements anyway, so the enthalpy change is going to be 0 anyway. So it's just going to be 4403. Ah, that's a trick. So we're not actually doing energy required to break bonds minus energy released when new bonds are formed. We're just doing energy required to break bonds, and that's my answer. 4403 plus 4403. Question 9. I think this is the last one. No, it's not. Second last one. The table below shows data for the 4 hydrocarbons: ethine, propyne, propene, propane. Delta Hc is standard enthalpy of combustion of these hydrocarbons. Complete combustion of 2 grams of one of both hydrocarbons releases exactly 100 kilojoules of heat energy. This hydrocarbon is. Complete combustion of 2 grams of this releases this much of heat energy, so that much of Q. Well, Q equals mc delta T. We don't have delta T. Instead, we're given delta H. So what we have to use is the other formula. Delta H equals Q divided by moles. So therefore, it's going to be Q equals delta H times by number of moles. No, you're not using my charger.
No, I promise you.
No, when I'll come down.
Okay,
Q equals delta H times by number of moles. Or what can we do instead? Yeah, Q equals delta H times by number of moles. Actually, no, we just work out delta H. That's just way simpler. We would just work out delta H. Yeah, okay, so it's going to be delta H in kilojoules equals 100 kilojoules divided by number of moles. Number of moles of what? Mass over mR. 2 divided by 26, 1 over 13. 100 divided by my answer, 1300 kilomole to the power minus 1. And that gives me the correct delta H using the Q. And obviously I could rearrange it. Q equals delta H times by number of moles. Delta H is 100 times by the number of moles, 1 over 13. No, not 1 over 13. Yeah, you get the point. And you should get A. Your answer is ethine. That was not too complicated. Delta is just Q divided by moles. Q is, yeah. And then just substitute that in. Q, 100, divided by the number of moles of ethine, will give me the delta H of combustion of 1300. Or yeah, Q equals delta H times by number of moles. And all we have to do in this case, do Q equals delta H times by number of moles, 1300, times by 2 divided by 26, and you will get 100 kilojoules of heat energy. Therefore, the answer is still A. And then question 10. Hydrogen is produced by the reaction of methane with steam. The reaction mixture reaches a state of dynamic equilibrium. Some enthalpy data is given in the table. Delta H is positive, 206 kilojoules mole to power minus 1. Use the information in the table and stated enthalpy change to calculate the missing bond enthalpy. Okay, so okay, so we've got delta H. Well, obviously we know delta H in this case, given bond enthalpies, energy required to break bonds, CH4, or if we draw out CH4, we've got 4 CH bonds, so that's going to be pretty easy. H2O, water, 2 OH bonds. So let's just work that out. 413 times by 4 plus 463 times by 2 OH bonds. 2578. We already know delta H. Should have included it. 2578. Energy required to break bonds minus energy released when new bonds are formed. CO. I think that should be an O here. I don't think that should be a H. Because where would the C triple bond H come from? You can't have that. Yeah, it should be a C triple bond O, I'm pretty sure. And minus a C triple bond O, which you don't know, plus H2. H2HH. But we've got a 3 on the outside, so all we're going to do is 3 times by 463. 436. Not 463. 3 times by 436. 1308. Now, what I have to do, 2578 minus 1308. 206 equals 1270 minus C triple bond O. 1270 minus 206. 1064. just rearrange it, and therefore the answer is B, 1064. Let's mark it. Question 5B, perfect. Question 6B, perfect. Question 7C, perfect. Question 8C, perfect. Question 9A, perfect. Question 10B, perfect. And that's the end of the multiple choice questions.